All right, folks. So this video is going to go over some basics about these little Garmin units. And honestly, this is for any simple type of GPS receiver. These, little, commercial pick them up for $100 or $200 or whatever. The brand shouldn't really matter. I'm going to go over the basics of how to get something meaningful out of this stuff. All right, and I should state I'm recording this for my own students and other students at my college who are interested in doing some kind of field research. So I'm not doing this like you're going out for a hike, but it still works the same way. Yeah, just some basic stuff. And I'm based in Southern California. I'm speaking to this from an American standpoint, so of course you would need to adjust this if you're going to work in another country. The maps and things like that change. Okay, so just keep that in mind. That's my little disclaimer. Okay, so let's turn this thing on. There's a little power guy on the side, and as this pops up, say what I'm going to do here is just take you through some key pages, and this is stuff that you should do before you go out. At least confirm, check this stuff before you to make sure the data you're getting are the data that you want and they're actually worth getting. Right? So down here, first thing to do, and I guess I should state the way to move through this because it's not obvious. By today's technology standards, you've got this joystick thing right here. So you can move it back and forth and up and down and all that, and that takes you through these different squares, which I don't know what the Garmin terminology is, but like pages or whatever. Okay, so I just use this to kind of cycle through, and when I get to the one I want, which in this case is setup, I push it. Yeah, it's awesome 1970s joystick technology right here, but it works for what we're doing. Okay, so I went into setup, and the first thing I'm going to do is I'm going to go into system. Okay, and there are there are two things in here that are important. There's this first one, satellite system, and then the second one, which is this augmentation stuff. The WAAS is Wide Area Augmentation System. At least I'm pretty sure that's what it stands for. The EGNOS, it's a European version of this. It's a way to increase accuracy of your for your GPS receiver. Okay, so if I were using this out in the field, at first in the satellite system, I would select what we see right here, which is GPS, which is our American system. The other one at the end there, that's the Russian system. Okay? And it's important to realize that GPS, it's not something given to us by the gods or whatever. It's GPS as we know it is an American system, and other countries and the European Union and China, Japan, other countries have been putting these things into place, mainly so they don't have to rely on us. Russia's no exception there. But what we can do is, if your receiver is capable of doing this, you can use a couple of systems, right? To just, what it means is it's going to help with your accuracy. You have a better chance of getting more accurate spatial data, location data, if you're using both of these things. Okay, so if I were actually out in the field, I'd have that on, and I would make sure to go down here, and I would simply turn on my WAAS, blah, 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 right? I think the only reason you would turn it off is it might extend battery life. So, if accuracy isn't the most important thing and battery life is, then you would keep this simpler, I guess. But at the same time, also just turn the thing off when you're not using it. But this is for the best accuracy possible, right? You want the settings to look like this. Now, that said, I'm inside right now. So what I'm going to do is I'm going to switch to this demo mode, which just means it's going to simulate some stuff. Because if you're inside, your receiver doesn't have a clear view of the sky. It can't actually see the satellites. it's not going to work, right? So rather than have this just look weird and do all sorts of stuff, we're going to make believe with this. Okay, that's the idea. Okay, so hopefully that makes sense. Now I'm going to go back so I can do that. Okay, and then another thing I want to do, get into units, and this really is just, it depends on you, right? And what it is you want to do here. So this one's set to statute, so it's going to be miles and miles per hour for speed stuff, distance stuff. Elevation is going to be in feet, but I can switch that to a few different things. Switch that to metric. Say if I want to do some, hardcore science, or if I'm European or whatever, same thing with elevation. You can change this stuff. Doesn't ultimately matter. It's all up to what you need to be recording this stuff in. Simple as that. All right, so I'll leave that there in the metric stuff. And then finally, from this part, this little screen here and this setup thing, you want to go into position format. And this is important. Now, this one here, it's set up to what I like to work in, which is this UTM UPS position format. And position format, what it really means, it's saying what coordinate system are you going to use here? Okay, yours, if you've just bought this, haven't changed anything at all, it's probably set to one of these decimal degrees or degrees, minutes, seconds, or whatever, one of these first three things here. Okay, this is latitude and longitude stuff, which if you need to be working in latitude and longitude, go for it, because you need to be doing it. But if you don't need to, by God, don't work in it. It's clunky and it's really difficult to use later on when you're trying to, say, bring the data into a GIS environment and actually map and analyze the data. Okay, so with any of this stuff, if you have a reason, like the map you're using to help you with your field work is all in latitude, longitude, decimal degree stuff or whatever, right? Have it match. Go ahead and pick that. But if not, I would recommend, and I went up to get to the end of this list. You can see there's a lot of different stuff in here, but the one I would select is UTM UPS. The UTM stands for Universal Transverse Mercator, and I'll show you how that displays when we get out of here. But that's the easiest thing I feel to work with, whether it's just using GPS and something like a USGS topographic map, or to bring this stuff in to put it into an Excel file and then bring it into a GIS environment. Okay, use UTM. All right. As far as map datum goes, yours might be defaulting to WGS 1984. The map datum, it's an origin point for your coordinate system. Okay, and you have multiple ones. If I press that, and you go through, there's just a lot of stuff in here. And I'll go up. There are really three that you would most likely see working in the United States here. The first one that we might have it set to, or you might need to set it to, is this NAD 27 CON US, for contiguous United States. I think that's what or continental US or whatever. But with that NAD, it's North American datum of 1927. Okay, so it's an older one, but we do still have some government documents that are in NAD 27, so maps drawn to that system. I worked for a government entity that took a while to get out of NAD 27. It wasn't until like 2005, I think, when they finally made the switch to this one, which was NAD 83, the North American datum of 1983. Okay? It's a better system than the NAD 27 datum. And so this would be, for the most part, if you're working with government maps, files of any kind. Most of the stuff is set to this NAD 83, right? So if you're doing some kind of government work or you're relying on maps themselves, you should be able to check. Any good quality map will have listed on there what the datum or the horizontal datum is. And so if it says NAD 1983 or NAD 83, you select this one, right? And then back down here, if we go back to that WGS 1984, there we go. That's the World Geodetic System of 1984. That one, it's not dependent on North America. So it's really, this is kind of like the native datum for just most kind of global GPS applications, right? So if you don't need to, pick one, if there's, let me put it this way, if there's not a reason to put it in NAD 83, just go ahead and make sure your datum is WGS 84, okay? And with this, have a notebook, right, as you're doing this work, and write this stuff down, okay? Because that datum alone is incredibly important, and if you don't have that, or don't have some record of what the datum is you're using, the mapping's not going to work. It's going to be a nightmare, okay? So you want to record that. And then this spheroid, you can't change it, so don't worry about it. And it's the spheroid refers to this a model of the shape of the Earth. It's not a perfect sphere. It's a funky looking shape, so we call it a spheroid in this case. Geoid is a more proper term of what the shape of the Earth is. But then we have these different models. Again, it's just to make our maps make sense and connect, and it will make your data that you take and collect in the field make sense. But you can't change these, so don't worry about it, okay? You can ignore that part. But once you have, if I go back here, that position format, the units, the system itself, once you've got that all set like I just showed you, you're good, right? That's key to being able to do this stuff. So that's the first important part of getting ready to use this stuff out in the field. Now if I go back here, I want to show you two other things. The first one, if I go down to the satellite page, and you can see there's a lot of stuff. You might get excited about hunting and fishing and all that, but play around with it. But it's not important for what we're doing here, right? For recording data. So some of this stuff is more recreational. Okay, but here, if I select that satellite page, it's going to take you to this. I think they call it the constellation screen. And so this, you can see down at the bottom, it's saying simulating, and that's because it's in demo mode, right? It's because I'm inside, I can't really show you this stuff. So this is an ideal version, and what it's doing is it's looking for satellites, your GPS unit itself. It's looking for these satellites, and once it finds them, it's taking information that the satellites are sending down to it. It's doing some work to figure out where exactly this unit is in relation to the satellites themselves. Okay? And so if you have at least three, you can do some pretty rough triangulation. Four is ideal to get some vertical stuff in there, but honestly, you just want more satellites, right? As many as you can possibly get. The more you have, the better your accuracy is going to be. And so this value here, that 3M, is 3 meters. That's my accuracy. Again, this is all make-believe, what it's doing here. So it doesn't currently have this. We have our UTM coordinates up here. It's all just, it's pretending. But when you're actually doing this, you're not in that demo mode and you're outside, what you'll see is this stuff will change. And initially, that 3 meters, it might be something ridiculous. It might be 20 meters or 50 meters or something like that. And it's really what it's saying is that the point at which your receiver, your GPS thing is at, which which is it's saying with these UTM coordinates there, it's saying these coordinates I'm giving you, yeah, it's within 3 meters of reality, right? Which, 3 meters, roughly 9-10 feet. Okay, that's about the best you can get these things to. If you're in an open area, clear view of the sky, you have, the US and Russian satellites that you're looking at, you have that WAAS augmentation stuff turned on, you get down to roughly 3 meters, 9 feet, okay? Which is great, honestly. For about 90% of the stuff that I do, that works, right? Because I'm looking more for big patterns. I don't need to get down to, within a few inches or centimeters of accuracy. So for, kind of big picture pattern stuff, that can work just fine. And you need to be thinking about, okay, is this okay for what it is I'm doing? If that's not going to work, that 3 meters, you need to invest in some rather expensive equipment, but that's what you got to do if that's what's important. Okay, so just think about that. For as you're getting ready to use it. So once you've gone through all that system stuff, setting up the units and the position stuff and all that, go to this satellite page and make sure that accuracy is where you want it, right? Or at a place where you're happy, and then you're ready to go out and actually start doing your work, hiking your transects or recording what's at your site or, whatever it is you're doing, okay? So check that. And then once everything's good and you're ready to actually start doing stuff, in here, this mark waypoint is going to be the most frequently used page that you've got. So if I select that, it'll take me to this screen. And a waypoint, it's a point. You see the little flag thing there. It's like you're planting a flag in this location, right? You're marking it, recording where it's at, all right? So up here, go up to the top, we have that 005. That's just a default thing. This is the 5th just random waypoint I've loaded into this right here today. If I click on that, I can change it from 005, but be aware, anything you're doing in here, you're gonna have to go through this joystick and slowly do it. It's a big, big pain, right? What I do, it goes back to always have some kind of little notebook with me. And so in there, I just write down, okay, waypoint 005, and then I actually name it in the notebook to save time. Same thing with this note section. This is going to take forever. So I just leave that as is, and I'll write any notes, any important contextual stuff in my notebook, and I'm set, right? And I'll also copy down the actual location, the waypoint itself, or the coordinates themselves. So to read this, the UTM, that's our system there, that 11 refers to the zone, and it's important to make a note of that, zone 11. The S, not as important in there, but this first stuff is just the zone. So zone 11, that's a big chunk of Southern California, is in UTM zone 11. And I would want to know that if I'm later going on and trying to use these coordinates with a map or putting it into a GIS or, something along those lines. So make a note of that, okay? Especially if you're not the one who's going to actually be mapping the data or analyzing it or whatever, at least initially processing it when you come back in from the field. Record everything, because it's going to be really unfortunate for that person who's stuck dealing with your data if you don't have any of this actually recorded. Okay, so just keep that in mind. Now the rest of this, right here, that 0391269, that's your easting, okay, as in meters east of a fixed origin point in this, specific UTM system. Okay, so you would read that. You can ignore the 0. It's simply 391,269 meters east. Okay, and then the one below it is your northing, or meters north. Look at that. And it's 3,831,055 meters north. Okay, and this will move as you're moving around. Again, I'm in this demo mode, so it's just, making up numbers for a location right here. But, for you, as you, continue to go through and record different waypoints, you should note that for the most part, the first handful of numbers aren't going to change, but these ones on the end will, right? Because it's referring to real meters. And this is why it's way better to work with than latitude and longitude stuff, because it's easier to envision and make sense of and all that. And as you'll see in a later video, when it comes to processing this stuff, it's easier for the computer to make sense of it, right? So record all of that. The elevation, these things aren't wonderful for elevation reading, so don't get too hung up on it, but you can if you just want some relative idea there. But once you've got that stuff, written down in your notebook, simply go over here and hit done, right? And keep walking around until you get to the next area where you need to record something, and then hit mark waypoint again, right? And just continue to do that. And you can go down to this waypoint manager down here. If you click on that, that'll take you to these other ones that exist in here, right? So you can go back like this one we just did. I can click on that. Let's say I forgot where it was, need to check my notes, something like that. I can reference it that way. And you can also, if you need to get back to that exact point from from the waypoint manager and clicking on it, you hit this go button there, and it'll show you how to get there, right? So it'll actually take you there. And that's why it can also be useful if you're, driving out to an area at the trailhead or wherever it is you're heading in. Take a waypoint of your car, and that way, if you're completely lost, you can have this kind of help you crash through the wilderness to get back to it, right? Okay, and that should be everything you need to know to go out and start using one of these things. Again, for simple, just data recording. Okay, with the idea that you're going to be able to bring this stuff back into some kind of computer system, into some kind of GPS, later on toward the end of the field work, right? So make sure, go over these things. These things are all crucial for it to work. But once you get that, this should be pretty easy to use. All right, best of luck, little scientists.